Yeah, I was going to ask you how I could do it like you, but apparently I am, because I got you 59 plus 20 here at the park as well, QSL.
Roger, Roger. 7-3, have fun in the park.
Thanks, Tom. Glad to get you in the log again. 7-3. KJ5CTS Motor Cures in.
Radios come in many forms, but two of the most common types are regular consumer radios and amateur, or ham radios. Although they may look similar on the outside, these two categories of radios serve very different purposes. Let's take a closer look at how they compare. Regular radios such as AM/FM radios, weather radios, and shortwave receivers are built for one purpose: listening. These devices are designed to receive broadcasts that are transmitted by radio stations or weather services. You don't need a license to use them, and you can only tune to preset or limited frequency ranges chosen by the manufacturer. With a regular radio, everything is one way. You can listen to music, news, weather alerts, or international broadcasts, but you cannot transmit anything back. Think of them as windows to the world of radio. You can look out, but you cannot speak through them. Amateur radio, often called ham radio, uses a wide range of radio types designed for different locations, operating styles, and communication needs. In this video, we'll explore the three major categories of amateur radios: portable radios, mobile radios, and base station radios. Each plays a unique role in how operators communicate locally, regionally, or even across the world. Amateur radios, often known as ham radios, take communication to a whole different level. Unlike regular radios, amateur radios allow two-way communication. You can transmit and receive, making actual conversations possible. Amateur radios support multiple modes of communication, including voice communication using FM or SSB, Morse code, known as CW, digital modes such as FT8, DMR, and many others, satellite communication, allowing contact through orbiting amateur radio satellites. To use an amateur radio legally in the United States, you need to earn an FCC amateur radio license. But in exchange, you gain access to a vast range of radio frequencies: HF, VHF, UHF, and even microwave bands. And, unlike a regular radio, amateur radios are highly customizable. Operators can choose their own antennas, power levels, operating modes, and even build or modify their own equipment. Ham radios are used for hobby communication, education, emergency services, and technical experimentation. Now, let's explore the types of radios operators use. Portable radios, especially handheld transceivers, often called HTs, are the most recognizable form of amateur radio gear. These small walkie-talkie style radios, like the Yaesu, ICOM, or Baofeng radios, are designed for close-range communication. The Baofeng is popular with new operators because of its relatively low cost. Portable radios operate mostly on VHF and UHF frequencies, which means they work best using line-of-sight propagation. In real situations, their typical range might be a few miles, but with a good repeater system, communication can extend much farther. Portable radios are battery-powered, lightweight, and ideal for staying connected during club nets, special events, or emergency situations where mobility matters. These radios usually transmit at 5 to 10 watts, making them efficient and reliable for everyday local communication. Another type of portable radio is the QRP radio. QRP refers to low power operation, usually 5 to 10 watts. The term comes from the Q code QRP, meaning reduced power. Even with low power, skilled operators regularly make long-distance contacts using high-frequency propagation, sometimes spanning continents. This challenges the operator to use efficient antennas, precise operating skills, and thoughtful technique. QRP radios are favorites for outdoor activities like summits on the air, camping, or field operations. Their small size and lightweight make them perfect companions when portability truly matters. Next are mobile radios, designed to be mounted in vehicles and powered directly from a 12-volt car battery system. These radios typically operate at higher power levels, drawing anywhere from 5 to 20 amps depending on transmit power. Mobile radios excel in citywide or regional communication, especially on VHF and UHF repeaters. They are extremely popular among technician-class operators and often support multiple operating modes, including FM voice, digital voice systems like D-Star, Fusion, and DMR, and even satellite work. The higher power output and better vehicle-mounted antennas, allow mobile radios to outperform handhelds in range and clarity. When acquiring a VHF/UHF radio, the operator has two choices: analog radio or digital radio. Analog radios use continuous radio waves to carry voice and sound. The operator speaks into the microphone, and their voice is converted into an electronic signal. That signal changes the radio waves smoothly, following the sound of the voice. At the receiving end, another radio picks up that wave and turns it back into sound again. Analog radios are simple, reliable, and easy to use. Digital radios work in a different way. When the operator speaks, their voice is changed into digital data, a stream of numbers. That data is sent over the air using radio waves. The receiving radio takes the numbers, rebuilds the voice, and plays it through the speaker. Finally, we arrive at base station radios, the heart of the traditional Radio Shack. These desktop radios are designed for serious, high-performance communication and require a dedicated, regulated power supply capable of supplying significant current. Base stations often cover the HF bands, which span from 3 to 30 MHz and support long-distance, worldwide communication through ionospheric propagation. Many base radios also include VHF and UHF capabilities, allowing the operator to work almost any combination of frequencies and modes. With full-size controls, advanced filtering, and large displays, base station radios provide an operating experience that's both powerful and precise. In amateur radio, every station, portable, mobile, or base, relies on one essential component, a dependable power supply. Before I talk about commercial power supplies, note that most amateur radios can be powered by batteries. They operate on 12 volts DC, meaning a car battery or a battery pack can power the radio. The issue becomes the size of the battery versus the wattage of the radio, as to how long the radio will transmit and receive. Now, let's talk about the two commercial types of power supplies. They are the linear and switching power supplies. Although they serve the same purpose, each one works differently and offers its own strengths and trade-offs. Let's take a closer look at how they compare. A linear power supply is the traditional style found in many classic ham shacks. It works by transforming high-voltage AC from the wall down to a lower voltage, then smoothing and regulating it using large transformers, heat-dissipating components, and heavy filtering. Linear supplies are known for their clean, stable output with very low electrical noise. This makes them ideal for sensitive HF operations where even tiny amounts of interference can affect reception. Linear power supplies have extremely low noise output, ideal for HF bands. Very stable voltage, even under load. Simple, rugged design with long life expectancy. Excellent for eliminating hash or radio frequency interference during weak signal operation. Linear power supplies are heavy and bulky due to large transformers. They are less efficient, producing more heat, and are usually more expensive than switching supplies. Not as portable for field operations. The switching power supply, often called a switch mode or SMPS, takes a different engineering approach. It rapidly switches current on and off at very high frequencies, allowing it to efficiently convert AC to DC using much smaller components. Switching supplies are lightweight, compact, and usually far more efficient than linear designs. Modern switching supplies also include RFI suppression features, making them much cleaner than older generations. Switching power supplies are lightweight and portable, great for mobile or field use. Highly efficient, producing less heat. Lower cost compared to linear models. Smaller footprint, easy to mount or pack for events. Power supplies can generate radio frequency interference or electrical noise, especially cheap or poorly filtered units. Noise may be noticeable on HF bands, depending on design. Less robust under heavy continuous load compared to large linear supplies. While I am talking about radios and power supplies, it is important to talk about a critical accessory that helps the radio system function efficiently in amateur radio. The antenna is one of the most important parts of an amateur radio station. But antennas don't always electrically match your radio perfectly, and that's where the antenna tuner comes in. Today we'll look at what an antenna tuner does, how it works, and the differences between manual and automatic tuners. An antenna tuner, more accurately called an impedance matching device, helps your radio operate safely and efficiently by matching the radio's output to the antenna system. Most radios are designed to work with a 50 ohm load, but real antennas rarely sit exactly at 50 ohms across every band. They may be too long, too short, or simply not resonant on the frequency you're using. The tuner acts like a bridge between your radio and antenna system, adjusting the electrical conditions so your radio sees the correct load. This reduces reflected power, allows the radio to transmit at full output, and protects sensitive internal circuitry. Inside every antenna tuner are components like inductors and capacitors arranged in adjustable networks. By adjusting these components, the tuner changes the electrical characteristics of the feed line and antenna system. Instead of physically changing the antenna, the tuner adjusts the impedance match so the radio and antenna can work together smoothly. It's important to understand that a tuner does not actually tune the antenna itself. It simply matches the antenna system to the radio. If the antenna is very inefficient, short, or poorly placed, a tuner can't fix that, but it can help the radio operate safely. A manual tuner requires the operator to adjust knobs or switches to find the best match. These tuners typically include controls for inductance, capacitance, and sometimes switching for different matching ranges. Manual tuners offer excellent precision and can handle high power levels. Experienced operators appreciate the control and flexibility they provide, especially when dealing with complex antenna systems like ladder line or multi-band dipoles. An automatic tuner, or auto tuner, does the adjusting for you. With the push of a button or automatically when you transmit, it quickly searches for the best match using internal relays and preset tuning combinations. Auto tuners are fast, convenient, and perfect for operators who frequently change bands or modes. They're especially popular in portable setups, mobile installations, and modern HF transceivers that do not include built-in tuners. Before I conclude this video, let me show you how a radio station is configured. A basic VHF or UHF radio station is simple and effective. It uses three main parts: the radio, the antenna, and the coaxial cable. The radio is the operator's control point. This is where the operator selects the frequency, adjusts the settings, and talks with other stations. The antenna is placed outside or in a clear location so that signals can travel freely. It sends transmitted signal out into the air, and it receives signals from other stations. The coaxial cable connects the radio to the antenna. It carries the radio energy back and forth, allowing the radio to communicate through the antenna. With these three parts working together, the station is ready to operate and make contacts. A basic HF radio station includes four main parts: the radio, the antenna tuner, the antenna, and the coaxial cable. The radio provides the frequency settings, microphone, display, and controls for communication. Between the radio and the antenna is the tuner. Like the VHF, UHF radio station, the antenna is the part that sends radio energy into the air and receives signals from other stations. Coaxial cable connects everything together. It carries radio energy from the radio to the tuner and from the tuner to the antenna. With these parts connected, the HF station is ready for communication across long distances. Amateur radio offers something for everyone, whether you're hiking a mountain with a handheld, chatting across town from your mobile rig, or reaching across the globe from your home station. Understanding the differences between portable, mobile, and base station radios helps new operators choose the right tools for their needs and their budgets. So do your research and choose carefully. Thanks for taking the time to watch this video. It's time to sign off, so I'll just say 73.